Hi, this is Sidra Khan, and in today's lecture, we are going to see what is cloud computing and how Microsoft Azure and IoT provide us opportunity to solve real life problems. What is cloud computing? What are cloud models? And Microsoft Azure IoT solution is the agenda of today's lecture. So, what is cloud computing? As its name suggests, the computing is done somewhere on the clouds or very far location from the user. As we know, the data is growing tremendously with the use of social media or with the processing of IoT or by using the services of internet. The amount of data is going in exabytes. So with growing amount of data, it is really daunting to maintain that data and do efficient processing. Speed is also a critical factor, and users do not want stall cycles. For example, if you are having an exam and you are searching for something on the internet, if your website is taking 2 minutes to give you the relevant response, you will end up closing that website because you will get fed up. You need speed, you need extra speed. So when we are dealing with internet, we take speed as a really critical factor. Exabyte of data needed to be stored somewhere in a really secure manner. Your corporate data, your data from IoT sensors, your whole amount of data has to be stored, has to be processed efficiently. So you need something really efficient for this. Data should be highly available to end user. If you're having traditional computing and your one server goes down, your all customers niche will have to wait or they will have to suffer. So we need to solve this issue that data should be highly available irrespective of the errors happening at the data centers. In traditional hosting, when we are having a traditional server, in traditional hosting, when we are having a traditional server, when one of our server goes down, our whole user have to wait or they have to suffer. While in cloud computing, we are having one server and its backup server. When one server goes down, its backup can provide the relevant servers. So, in this case, the services are provided to the users in cloud and it can solve fault occurrence, high speed issue, high availability issue. The infrastructure is managed by cloud service provider. We do not have to worry about this. And the security of data is also managed by cloud service provider. We do not have to worry about this. How cloud is deployed? There are three deployment models. One is public cloud, the cloud which is available for the public use. The most common examples are Google, VMware, Amazon, IBM, and Microsoft Azure. By using public cloud, you can use their services by paying for what you use. So these services are available for public. The next is private cloud. In private cloud, if you're having your corporate organization and you want your data to be very private, you can establish or you can take services of the cloud and make them very private. So this is the private cloud model. The next is hybrid cloud. In hybrid cloud, we take services of public cloud and private cloud. For example, if you're having your corporate business, you set up your private cloud, and for your web services, you want public to view that websites, you can use services of public cloud. So in hybrid cloud, you are having combination of both public cloud and private cloud. The next is cloud service models. How cloud provides services. The first thing we will discuss is infrastructure as a service. In infrastructure as a service, cloud service provider allows you to create your virtual machines or servers, to manage their security, manage their capacity, manage their networking protocols. So Cloud service provider allow you to manage your infrastructure in your way. So in this case, you have to pay very minimum cost for the services you are using because the other management is done by you. So this, as its name suggests, it is infrastructure as a service. Cloud service provider is providing you infrastructure as a service, and you can modify it as per your needs. For example, in AWS, you can create EC2 servers, you can host your websites, you can manage its security, manage its storage, and manage its networking protocols. The whole thing depends upon you. The next is platform as a service. In this cloud service model, you are responsible for managing your application. The platform is provided by the cloud service provider. Companies can run predefined platform for software development. For example, Microsoft Azure. You are having your website. For example, you are having your website in PHP. So you are going to use the platform developed for PHP, and you can host your website on this. You can customize your website according to your needs. So you are only using the platform for hosting your website. This is platform as a service. The next is software as a service. In software as a service, you are going to use a ready-made software. You are not responsible for managing anything. You do not have to worry about the security, the networking, the storage, anything. You are only responsible for your data, and you have to use the ready-made application. In this case, you have to pay a high cost because you do not have to manage anything. You're not managing anything. You're not doing any work. The whole work is done by the cloud service provider. The very common examples are Microsoft Office 365, Dropbox, Google Drive, etc. How cloud actually works. There is a client wants something from the cloud. So when client requests something from the cloud, first thing is his identity, which can be stored in the form of cookies. So his request in the form of cookies is sent over the first tier server. The first tier server is a lightweight server which is hosting a static web page, HTML web page, for the sake of showing response to the user of his request. So when the request comes from the client, his identity and his cookies and his request comes to the first tier server, which acts like an gateway to the backend servers. So this is your static content, static web page, which is only responsible for displaying the relevant response to the user. The request from here goes to the backend servers in the form of message through a message bus. Messages are nothing but a stream of bytes. So your request goes in the form of stream of bytes on a message bus which is having queues. So for which microservices your request is, your request goes to the relevant microservice. Here the processing can be done. The service discovery part shows that your request goes to the microservices. For which services your request is, it can be identified in this section. And after the processing, your request goes back to the API gateway, and through content delivery network, your request has been processed and the relevant response is sent to the client. Here, what is content delivery network? For example, we are using AWS services. AWS is having its data centers worldwide, globally. So when user is in Pakistan and he requests something, so he needs low latency or high speed and high available data. So AWS will provide data from the nearest data center. When this user will be in US and request something, the AWS will provide data from its nearest data center. So content delivery network is basically providing low latency data, or the speed of data. As we have discussed in the first slide, the speed is very critical factor. So Content delivery network is responsible for providing low latency or high speed data to the user from its nearest data center, as public cloud service providers have data centers globally. So according to client location, CDN will provide data to the client as per his nearest location. What is microservice architecture in cloud? As we have seen on second tier, one service is sharded into multiple microservices to induce concept of parallelism. Microservice architecture is responsible for handling more users, more fault tolerance, and for better service delivery. Here we have one service. For example, we are having database. We divide our database into 4 smaller sets of database. If requests are coming for this chunk of the data, the whole request will be processed by this chunk of the data. These chunks will not have to suffer because of multiple requests on this chunk of data. If we are having requests for this chunk of data, they are getting processed here. For this chunk, they are getting processed here. So in this case, parallelly, we are serving more number of customers as compared to monolithic architecture, where whole server was responsible for serving all the customers. If we are having many customers and multiple concurrent requests, microservice architecture can serve them in better way as compared to monolithic architecture. Now we will see some Azure service which we are going to use in our solution. The first one is Azure Service Bus. What is Azure Service Bus? We have a client or we have client application. It can be a website or a mobile app. It sends request to the cloud. As we have seen previously, this request goes to the processing unit or the backend server in the form of messages. Messages are nothing but a stream of bytes. Here we are having message queue with messages. Here we are having multiple services. For which service this message is, it goes to that service and get processed and get back to the user. Data is transferred between different applications and services using messages. The message is nothing but a strip of bytes, a container which can hold any amount of data in any form. For example, we are having web app, mobile app, and other services. They are requesting data from the cloud. The message bus or the service bus will have a message queue where we are having all the messages from the senders. Here we are having multiple microservices. For which service is this message is, this message will go to that service, get processed there and get back to the sender. So this is the work of Microsoft Azure Service Bus. The next is Azure Web Role. Azure Web Role is a part of cloud service. Web Role automatically deploys and hosts web application by using IIS server. It is a platform as a service model of Azure and supports scalable, reliable, and inexpensive web applications. You can host your website on Azure platform with customizations by using Azure Web Role. For example, you create a web role in Microsoft Azure. You can host your web application as per your requirements. For example, if you are having .NET or PHP website, WebRole automatically deploys and hosts any website developed on programming languages. You can create WebRole specific to your website or your application and host your website by using IIS and Microsoft Azure Service. Now your website is hosted on a web role and you need to do some processing over your data. So for that purpose, you will use Microsoft Azure Worker Role. Worker role does not use IIS. IIS was using for hosting of web application. Microsoft Azure worker role is any role in Azure that runs service level tasks, that is doing backend processing level tasks. Worker role usually support background processes along with web role. The website which is hosted on a web role, its processing is done on the worker role. Let's try to understand with this example. For example, you have hosted your website on the web role. You are having load balancer here, which is dividing load on these web roles. This web role instance is connected to the worker role. The processing on data of this website is done on the worker role instance. The communication between them is done internal network node or a message bus queue. You can store processed data into any Microsoft Azure storage. So here we can get a clear view of web role, which is responsible for hosting your website, and worker role is responsible for doing processing over your website. The next Azure service is Azure Tables. As we have seen, we are having tremendous amount of growing data. We need to store that data in an efficient manner so we can process that with speed and high availability. Storing terabytes of structured data capable of serving web scale applications is a daunting task. We need quick querying data using clustered index. We do not want to traverse over the tables by using primary keys, foreign keys, by normalizing or denormalizing, as it takes a lot of time. So Microsoft Azure provides us the service of using NoSQL database. With NoSQL, we mean as in uh, relational tables, we are having primary keys and we define our column names and we have to store data according to these fields. But in NoSQL tables, if you are having name, ID card, and your phone number, in another row you will have ID card number, your city, your father name, and other data. So this is not a restricted form of data structures. That is the main concept of NoSQL database. Here you have one key we can say it's a key value pair, one key, and you are having multiple values here which are not restricted by column names or column definitions. So when we store data in Azure tables, it do not require complex joins, foreign keys, or stored procedures and normalization or denormalizations for fast access. For example, here we are having our website, our web role, and it is storing data in the form of tables. Here we have message bus where our messages or our requests are going to the second tier or processing units. So here we are storing our data in the form of blobs, and worker service is using data from here, and this data can be transferred to the first tier. What is blob storage? As we have seen, tables are responsible to store large amount of NoSQL data. The blob storage is responsible for storing unstructured data. For example, here we are having images, we are having video files, we are having text images, text documents, we are having PDFs. So all forms of data are getting stored in the form of blobs or binary large objects. This is a simple example of how scalable roles are created in Microsoft Azure. The next thing is how we can connect with Microsoft Azure Virtual Network. We are having our physical data centers. We want to connect our data center. We are taking services from Microsoft Azure and we want to connect with Microsoft Azure. So we want a secure connection between this. To connect with Microsoft Azure, as we can see, we have a local network gateway or Microsoft Azure secure gateway. We have to pass through this gateway to enter into the Microsoft Azure network. So when we want to connect our physical data center to Microsoft Azure, we want a secure connection and to connect with gateway to enter into the Microsoft Azure network. Let's say we are having our head office here and we want to connect our head office to the Microsoft Azure. We can use VPN or Express Route. Express Route enables you to create private connection between Microsoft Azure data center and your infrastructure. Data do not need to go over the public internet. You are having your own private connection. You are not using private internet. Public internet. When you are using VPN, your data traffic goes over the public internet by using a secure connection. In this scenario, we are using public internet but creating a secure pathway to connect our physical data center and Microsoft Azure network. In Express Route, we are creating a secure private connection and do not using any form of public internet. And to enter the Microsoft Azure network, we need to have Microsoft Azure Virtual Network Gateway. The next service is Azure IoT Hub. As its name suggests, the hub is responsible for communication. So it enables highly secure and reliable communication between IoT applications and devices. You are having sensors, you want a secure communication and data transfer between them, so you can use IoT Hub. The next is Azure IoT Hub provides a cloud-hosted solutions backend connect virtually any device. You are having sensors, you want your data from sensors to go onto the cloud. You can use Microsoft Azure IoT Hub services. You want authentication of your devices, you want to maintain your devices, you want to maintain over the air updates of your sensor devices, you can use IoT Hub for that. Basically, when we are dealing with IoT Hub is our central power. Security enhanced communication channel for sending and receiving data from IoT devices. For example, if I am having multiple sensors here, instead of connecting all these sensors with each other and establishing communication between them, I can use IoT Hub. IoT Hub will be responsible for managing all these sensors, data, and to provide relevant output. So we can say IoT Hub acts as a centralized location for managing multiple sensors and their respective outputs. Over the air updates. Device update for IoT Hub enables over the air deployment of updates to help keep IoT devices up to date and secure. For example, we are having multiple sensors, multiple IoT devices, and we want to update those devices. By over the air updates, we mean if our sensors, let's say we are having these sensors, if our sensors are connected to internet, we can update our sensors by using IoT Hub. If one of our sensor is not connected to internet at that moment, as soon as it will get connected to internet, our IoT Hub will be responsible for updating this sensor. It will send update to this sensor and this sensor will get updated. It is not headache of cloud now. It is not headache of service provider now. He has sent updates in the IoT Hub, and now IoT Hub is the central power. It is responsible for updating sensors. So when we are having multiple sensors and we want them to get updated, we use IoT Hub to update these sensors. If these sensors are connected to internet, they will get readily updated. If one of the sensors is not connected to internet for a moment, as soon as it will get connected, it will get its update from the IoT Hub and it will get updated. The next is hybrid IoT applications. Compatibility with Azure IoT Edge for building hybrid IoT applications. IoT Edge are basically containers that run Azure services, third-party services, or custom codes. We are having third-party applications and we want to connect our sensors data and we want that output in the third-party applications. So we want some mixture of Azure IoT Edge services, Microsoft Azure IoT Hub services, and third-party applications. So this mixture can be implemented by using IoT Edge and Microsoft IoT Hub. The next is event-driven approach. Event Grid is highly scalable broker that you can use to integrate applications using events. For example, events are delivered by Events Grid to destination applications, other Azure services, or any other endpoints. You are having a centralized service and you are having multiple applications here. When any application generates an event and this event has to be delivered to this application, Event Grid is responsible for delivering this to this application. This application does not need to be directly communicate with this, with this, with this, or this. The whole communication of events is managed by the Event Grid. So full integration with Azure Event Grid and serverless compute simplify IoT application development. We are having sensors. On the basis of sensors, if we are generating some events, for example, if this sensor is malfunctioning and generating some events and we want this event to be communicated to these multiple applications, so Event Grid will be responsible for transferring this to other applications. This application does not have to communicate with all other systems. Now we are having a real life problem, water management. As we know, water has been a very critical factor in our domestic lives, in industrial lives, or for marine life. We have to manage our water usage. For example, if you are having a building having multiple hundreds of apartments and you want to track water usage. If one of your customer leaves the tap open the whole day, your water has been wasted. You want to track this. How you will do this? You can deploy sensors by looking at this picture. When we have a water line, we can have sensors, and these sensors can be connected using Wi-Fi. By getting data from these sensors, we can analyze from which pipe the water is overflowing or the water is getting wasted. We will look into the details in the further slides, but this is the concept of smart water metering. How we can monitor usage of water. Saviant is a company which provided the solution. The simplest form of explanation is data from smart water meter sensors is collected. We have created a website or a web role in Microsoft Azure. We get this data into that web role. To do some processing over this data, to analyze this data on the basis of past usage, that how much water has been used, or is it getting wasted, or is it in the normal range, how is our sensor health. If we want to process this data, we have created worker role for that. And worker role, on the basis of analytics or the processing done on the worker role, we have developed a web application or mobile application on which we can see the whole data. So this is the main concept. Smart water metering solution is using Azure Platform as a Service. As we have discussed, Platform as a Service allows us to use the platform provided by the public cloud service provider to host our solution as per our requirements. For example, this similar solution can be implemented for a factory or for a for a factory or a manufacturing company in a different way. But for a housing scheme or for a colonies colony water management, the same solution can be implemented in a different way. So we can do customization as per our requirement in the Microsoft Azure platform as a service. In implementing smart water metering solution, our challenge was to connect smart sensor water meter to Azure cloud to create a smart solution. We have to track real-time water consumption. We have to collect data from domestic water meters across US using AMR via CDMA chips and Verizon. Here, we are talking about smart water meters and Verizon is a wireless network connection. We have to collect reading from all meters in minimum time. As we have discussed, speed and time is a critical factor. And also we want long life battery of smart water meters. These are our some challenges. And what we want in the outcomes. We have to track real-time water consumption. We should have screen defaulter from overconsumption of water resource. For example, if one sensor is indicating that in that tap or in that apartment the water is getting overused or the water is getting wasted, we should be able to view that on our mobile screen or our laptop screen. We want load balancing. For example, if we are having 50,000 sensors, we are having 50,000 meters, so we want to manage the load. Frame strategies for saving water resources, and the output or the data analytics should be clear enough so that we can form strategies to save water. The next thing is how to deal with infrastructure cost. In the form of words, this seems very simple that you have 50,000 sensors, you deploy them into the water tanks or water pipes, and you get the readings. But in real time, how we are dealing with the infrastructure cost? We can implement smart metering using IoT. Smart water meter sensors should be integrated with Microsoft Azure cloud services. Integrate water meters with cloud to create IoT environment. This data will offer bidirectional analytics to customer as well as client. Let's see this in details. We are having this solution. We are having our smart water meter with sensors. The sensor data is going by using Verizon core network to the Verizon network. Let's suppose, for the sake of simplification, here we are having our data collection center. The sensor's data is getting collected over here by using a VPN, a secure channel. We are transferring this data to Microsoft Azure. Now, in Microsoft Azure, we have developed a web role for a meter service. Here we are getting data from different water meters, and this data is getting into the Microsoft Azure web role, a website which we have deployed as per our requirements. Now, we want to do some processing over this meter data, over the past experience, or we want to analyze this meter data. We will transfer this data to the worker role. As we have seen, worker role is responsible for doing some processing over the web role. How we will transfer this data? We will transfer this data in the form of service bus queue. As we have seen, service bus has bytes or a stream of bytes to transfer this from this point to this point here, when data compactor will do some processing over our data, the processed data can be stored into the Microsoft Azure table storage. And on the basis of this storage, we have created another web role to display the output to the third-party application, to the admin and to the user. For example, a user has also installed an application on his mobile phone, and an admin has also a web portal here. Both can see the respective output of the water usage. So this web API or this web role is responsible for providing relevant output to the third-party application. So as we have discussed different Microsoft Azure services in the previous slides, in this solution we are using similar services. Microsoft Azure provides staging area to the developer, where developer first uploads the application, and when application is ready to go live, they use Azure portal and swap staging with the production. So in this case, our web role is hosted. By using service bus queues, our data is sent in the form of bytes to the worker role, where the processing or backend procedures is done on the data, and the data is stored in the Microsoft Azure tables. On the basis of this stored data, if we want to show analytics to the user or to the admin that how much water is getting used, we can create another web role, and by using web API request, we can transfer this data to the admin, to the third-party applications, or to the utilities. So we can see how Microsoft Azure simplify this whole procedure, how this can be done by using IoT and Microsoft Azure. In this solution, we have used Microsoft Azure Platform as a Service, Microsoft Azure IoT Hub to manage data from IoT sensors, Verizon Wireless Network, Microsoft Azure Table, and Microsoft Azure Bus Queue. We were discussing some challenges, so now we will see how we have achieved our goals. This solution provides real-time visibility over water consumption to consumers and utilities, a multi-tenant web portal for utility companies and mobile apps for consumers to view the capture data. As we have seen, we are having this web role to provide insights of data to the admin or the utilities. With the data analytics engine in place, the system also generates analytics for the user to get real-time insight on water consumption. It is designed to generate 22 alerts on conditions or anomalies such as overconsumption of water resource, billing, leakage detection, and others. The system features two-way communication between cloud service and CDMA-based water meters with communication time logged at 200 to 300 milliseconds. By this solution, we achieve the critical factor of speed. Utilities can also monitor the health of smart meters using this robust IoT solution. So this was our main concept of this lecture. As we can see, everything in IoT is a digital twin. What we have physically, we can have its digital twin. We can monitor its digital output in an efficient manner. By using this simple solution, we are solving a very, very crucial problem of today's era. For example, in Pakistan, we are having very critical condition of clean water, the water which is available for drinking. If we can track consumption of water efficiently, we can store our water efficiently, and we can provide water to the needy in an efficient manner. So this was about today's lecture. I hope it makes I made some points clear at this point. Thank you.